Hey, everybody. What we are going to do today is we are going to start talking about ratios and proportions, and we are going to do our 5.1 notes for pre-algebra. All right. And today we're going to be talking about ratios and rates, many of which you've probably seen or heard of before. But this is going to be our foundation to eventually solving and writing proportions that are going to be a little bit different from what you've maybe seen before. Okay. So we're going to start with a little vocabulary and then we'll dive into using this in practice. First off, what makes something a ratio? A ratio at its simplest is a comparison of two quantities. And there's a few ways that we can end up in math showing a ratio. We could say first, one way we could say would be 3 to 4. All right. If I was to verbally talk about it, I have a ratio that's 3 to 4. Now, how could I also write that? I could write that as 3:4. All right. And that colon says it's 3 to 4 here. All right. And our third way is I could write it as a fraction. I could say option 3 is to write it as 3/4. Now, I'll tell you as we get this later, we often want to end up using variables, or we need to clearly state what is one over the other, because a lot of times there will be, units associated with this. Okay. Now, what makes something a rate? Well, as I said, um, we might end up having different units. So a rate is a ratio of two quantities with different units. So let's say we are going 60 miles in 2 hours. Right now, I just gave us a rate. Okay. Now, let's go to what might even be more helpful than just having a rate, and that is a unit rate. A unit rate is a specific type of rate, and it is a rate with a denominator of 1. Okay. So what's the most common unit rate that we probably see all the time would be 30 miles per 1 hour. And common being not necessarily specifically 30 or 1, but this is the unit rate for that. 60 miles per 2 hours is a rate. We can convert that into a unit rate of 30 miles per 1 hour. Okay. And what I meant is common, 30 miles per hour is a pretty common unit rate that we always see. So let's get into some examples. Example 1. There are 45 males and 60 females in a subway car. The subway car travels 2.5 miles in 5 minutes. All right. So let's first end up finding a ratio for males to females. So I'm going to put males over females. And there are 45 males for 60 females. And again, this is a fraction. You should be thinking if we were having a fraction, we should always put it in simplest form. 45 over 60 is 30/4. And that here is our ratio. Now, I didn't right now put any units. And that can be okay at times because I'm specifically saying male to female. But I would generally like us to, at times, put in those units here. Okay. Times I'll be picky, times I will not. All right. I don't technically always need them because I'm saying it's males to females, so we should know what each number associates. Still important. In this case, part B, find the ratio of females to males. So we know we want females over males. Thus, there are 60 females and 45 males. 60 over 45 simplifies down to 4 over 3. Okay. Now, what about the ratio of females to total passengers? Well, we need to find the amount of females over the total people in that subway car. Well, we know there are 60 females out there, and we know the subway car has not just the 60 females, but also the 45 males. So we get a ratio of 60 over 60 plus 45, 105. Now, hopefully some of you are able to realize that we need to still simplify this down. That simplifies all the way down to 4 over 7. Okay. And there are 3 examples of ratios. Now, I just realized I end up saying A, B, C, and then B again. But part D here, what it should be, that final question here, find the speed of the subway car. Now, if you're ever thinking speed or something like that, we need to find the unit rate. Now, generally for a unit rate, you'll specify what I'll specify what I want as the denominator. Maybe it's miles, maybe it's minutes in this case. Generally with speed, we're putting the time on the bottom. So we can end up having here, we know that our speed is 2.5 miles per 5 minutes. Well, I need to get this to a unit rate that's over 1. So I'm going to divide both the top and the bottom by numbers by 5. Why? Because 5 divided by 5 there gives me 1 minute in the end. And now then I know the bottom, the denominator being 1, that's going to be a unit rate. So let's finish this up. What's 2.5 divided by 5? That's 0.5 miles. So we have 0.5 miles per minute, 1 minute. And even though we normally never have decimals in fractions, it's okay in this case because we're specifically using it as a unit rate. And note, because this is a rate, I need to also make sure that I'm having my units mentioned. Okay. So let's move on here. All right, let's continue here. The table shows the cost of different amounts of artificial turf. Find the unit rate in dollars per square foot. So first off, let's make sure that this is a proportion here. We haven't introduced that, but that all of these fractions, all right, are equivalent. And if you notice, we go by times 4 everywhere on the bottom, and we go times 4 on this top row. All right. And because each thing is equivalent, we're going times 4 here and times 4 up above, times 4, times 4, times 4, times 4. It means that this ratio and rate is going to be equivalent no matter which of these numbers we go about. If we had maybe times 4 here, so 100 times 4, but then times 2, you wouldn't have an equivalent fraction. And thus the rates wouldn't be equivalent. So let's dive into this again. We know that we wanted unit rate in dollars per square foot. So that means we're looking for the dollars per meaning over feet squared. So even though this is square feet up above and costs in dollars on the bottom, we want dollars per, so dollars above. So we can take any of these because we know they are the same and plug in some numbers. So $100 for 25 feet squared All right. Just grabbing that from there. That simplifies down to $4 per 1 foot squared or square feet. All right. And now I have a unit right here. Okay. So let's flip this over and we got 2 more examples. So what we have here now is we have one of the first graphs that we've seen on an XY coordinate plane in pre-algebra. And let's talk about this. All right. First off, let's read the question. The graph shows the speed of a subway car. Find the speed in miles per minute. Okay. So remember, we want here when we're finding speed, that's going to mean unit rate. And we want miles over minutes. Okay. And so we have our first graph here. We have this x-axis, which is the horizontal axis, which represents minutes. We also have our y-axis, which represents miles. So if I look at any of these points, the first point of the coordinate is always representing our x value, and our second comma is that number is the y value. Okay. So in this case, I look at this here. I know in 3 minutes, I've gone y miles, 1.5 miles here. Okay. So I can take any of these points now and plug it in. Now, what's really important is if you take a point, you take a point that's directly on one of our, grids. We don't want to estimate like this one, or one that's given. So I'm going to take this first one that's given, 1/2 comma 1/4, and say, hey, we go 1/4 mile in 1/2 minute. And let's simplify this down. There's a couple ways that we could do this. I could times this by 2 to get a denominator of 1, or I could do the following. I could say 1/4 divided by 1/2, because that's what we're doing here, a fraction, and solve for that. So 1/4 times 2 over 1. That simplifies down to 2 over 4, which simplifies down to 1/2. So we know now we're going 1/2 mile per 1 minute or per minute. And that here is one of our first examples. Okay. Let's do one more. This one's a little bit tougher. All right. And let's see the following. You mix 1/2 cup of yellow paint for every 3/4 cup of blue paint to make 15 cups of green paint. How much yellow paint and blue paint do you use in total? All right, so we know we need a 15 total cups of paint, and we need not half of that total paint, but for every 1/2 cup of paint of yellow, there is 3/4 cup of blue paint. So we can do this in a couple ways. Method 1 is we can make a ratio table. All right, so I'm going to make a table here. And what I'm going to do is I'm going to end up putting my cups out there. And I know for every 1/2 cup of yellow, I have 3/4 cup of blue. All right, and that means that in total, if I did that once, I would have 1/2 plus 3/4. That gives me, all right, 1/2 plus 3/4. That gives me 5/4 cups of paint. All right. So I have a little bit of a table here. All right. And I know I want to get to a situation where I have 15 total cups. Well, I could figure out 5 times what gives me 15. All right. And then I would multiply both 3/4 times that number, 1/2 times that number, and that would show this ratio. I don't know that off the top of my head, so I'm just going to figure out if I had these all as whole numbers, what would I do? Well, I could times this by 4. What's 5/4 times 5? 5. What's 3/4? Sorry, 5, not 5/4 times 5. 5/4 times 4 gives me 5. All right. What's 3/4 times 4? 3. And 1/2 times 4 gives me 2. Now I know here that for every 2 cups of yellow paint and every 3 cups of blue paint, we have that ratio. Gives us a total of 5 cups. All right. And why did this work? Because of these proportions that I'm doing and multiplying everything by the same. All right. So that this next line is all multiplied by 4. From here, I can take this and multiply it by 3 and say, hey, 5 times 3 gives me 15. If I have 5 cups, I multiply by 3, I'll get 15 cups. Well, let's just take this same ratio, multiply it by 3. 2 times 3 is 6. 3 times 3 is 9. So now 6 plus 9 gives me 15 total cups. All right, and that's what I wanted. 6 cups of yellow to 9 cups of blue. All right, and I wrote it as a ratio, but that answers that question. There is one other kind of way that we can go about this. And that's using some fractions. Everyone's favorite thing. Okay, so I can find here a fraction of green made from yellow. Okay. So I know for every 1/2, that 1/2 is a fraction of 5/4. So I have a fraction of 1/2 over 5/4. Really, what I have is a ratio of yellow to our total. All right. Well, let's simplify that down. That's 1/2 times 4 over 5. 1/2 divided by 5 over 4, keep change flip. That simplifies down to 4 over 10, which simplifies down to 2 over 5. So for 2 yellows for every 5 total cups, which we also found up there. Well, now I know that if I want to find the amount of yellow of those 15 cups, we can use this ratio. All right, I can use this fraction. I also know now that a fraction of G, that green, is blue. All right, which is going to be 1 minus 2/5, which gives me 3/5, 3 blue to 5 total. And now I can just use that. So I can say 2/5 times 15 gives me 6 yellow, and 3/5 times 15 gives me 9 blue. And there I have, whoops, my final answers here. I apologize for putting that down. So 2 different ways that I can kind of go about this. All right. Can end up making a fraction of one versus the other. And then now I know this is the fraction of the total. All right. And I can know as long as I have 15 or whether I had 4,000 cups, I know that 2/5 of that 4,000 would be yellow and 3/5 of that 4,000 would be blue. So that is one way to go about this. And that is our 5.1 lesson.